S. Chan presents educational video lectures as per the new UGC CBCS curriculum. Absolutely free. Difficult concepts made easy. Study anywhere, anytime.
Hello everyone, in this lecture we will be learning how to form a partial differential equation in different situations. It means suppose if we are given two functions, after eliminating the two functions, how you will be coming to or forming a partial differential equation. Suppose you have two unknown constants, then removing the unknown constants to form the partial differential equation. So, we will be learning in this lecture. Welcome to S. Chand Academy. I am Dr. Seema Thakran. So, if you want to study this topic in detail, please refer to the book by S. Chand Publishing. The e-book link is given in the description box. So, let's start with formation of partial differential equations. There are particularly three situations where we will be just getting the partial differential equation. So, let's start with formation of partial differential equation. Before starting the lecture, in the last lecture I taught you order, degree, linear and non-linear partial differential equations, but now I will be just first give you some notations to make the problem or to look the partial differential equation little or in a convenient way. Otherwise, every time writing partial differential equation is anyhow lengthy. So, we will just have notations. So, first is p, small p, and I have given this, suppose my function is z equal to fxy. So, when I will be differentiating, it means this is dependent variable and these two are independent variables. So, z derivative with respect to x I am calling as small p. These are anyhow standard notations for partial differential equation. Then the partial derivative with respect to y I will be just giving a notation q. Then for r it is del square z upon del x square. For s it is del square z upon del x del y or del square z del y del x. For t, this is the notation, it means the second partial derivative with respect to y. Then for s it is this. What does it mean? We did it in the first semester when the concept of partial differential equation, not in detail we did, but little basic lecture we had for partial differential equation. So, there I told you it means partial del by del x of del z by del y. It means first you differentiate with respect to y and then you differentiate with respect to x. Same way this derivative means this. So, it is clear that first you will be differentiating with respect to x and then you will come to for the derivative with respect to y. This is how you read these two notations, these two partial derivatives, and I have given notation as s. So, these are the standard notations p, q, r, s, t. Now, coming to the formation part. So, this lecture I have divided in three parts you can say. In first part I am taking the problems where you are given some constants and you will remove those constants. How you will remove to get the partial differential equation? So, I am taking first the part removing the, I call this part as removing the constants to form partial differential equation. So, first question I am taking and that is 2z equal to x square upon a square y square upon b square. So, it is very clear in the beginning I have told you z is fxy. Z is fxy, and now what are the constants you have to remove? It is not partial differential equation, you can see this is 2z equal to, it means to form partial differential equation we should have partial derivatives in the equation, and to have partial derivatives it means you have to differentiate it with respect to x and y, and clearly my function is function is of two variables clearly. So, it means it is more than one variable. So, you will be just differentiating and you will get partial derivatives when you will differentiate. So, z is fxy, a and b are the constants to remove. How to remove? Let us see. So, first step, when you will form partial differential equation, first step will be taking the partial derivative with respect to x and y. This will be the first step. So, for the solution, differentiate partially the given equation with respect to x and y respectively. So, I have already told you how to take partial derivatives. In partial derivatives, what we do? We just, if we are taking it with respect to x, x will be treated as variable, others will be treated as constants. So, x will be, if I am taking it with respect to x, it means 2 del z by del x, z derivative with respect to x will be del z by del x. This is constant, it means the derivative will be 0. Now, derivative of x square is simply 2x, 2 will gets removed, it means this I am just solving only for x first. Now, come to, I have numbered it as 1, now come to the partial derivative with respect to y. So, this is with respect to x and now with respect to y. The same way obviously you will treat y as variable and x as constant. So, the derivative will be 2 del z upon del y 2y upon b square, 2 will get cancelled. So, it means on similar lines you are getting this equation. How to remove the equations? Now, see, first you should, the only way is these two partial derivatives will help to get the partial differential equation or the given equation. If it is fine and we are able to remove the constants with the help of first order partial derivatives, then it means it is fine. Otherwise, we have to go to the second order partial derivatives. So, in this case, let us see what actually the situation is. So, you can see if I multiply, I just see the equation first. So, my equation is x square upon a square, here it is x upon a square. It means if I just multiply it by x, then x square upon a square I will get. Then if I multiply this by y, I will get y square upon b square. It means this type of form I am getting if I am multiplying the first by x and the second by y. So, and then if I add and substitute instead of this, if I substitute 2z, it means my a and b are removing completely. So, you should see your equation, given equation, to observe or to see like what are you supposed to take second order derivatives or not. But in this case it is not, there is no requirement. So, it means these three equations, one is the given equation and the other two are the derivatives, partial derivatives with respect to x and y. So, these are sufficient. So, what I am doing? I just multiply this equation, I just write this as number 2 and I just number it as 2 and this is as 1. So, multiply 1 and 2 by x and y respectively. It means you are multiplying 1 by x and 2 by y. So, you will get x into del z by del x equal to x square upon a square, then y into del z by del y, y square upon b square. So, this is third, this is fourth, add up these two, adding 3 and 4, we get x del z by del x plus y del z by del y equal to x square upon a square, and simply by the given equation you can replace it by 2z. So, this is the equation we were looking for. So, it means x into del z upon del x plus y del z by del y is our equation, partial differential equation. You can see this equation is having partial derivatives and there is no a and b now. So, this is the example of where we have removed the constants. So, taking one more example of the same type. and the equation is same two constants we have. How to remove in this case now? It is in multiplication form. So, first step will be standard one. So, it means you will be differentiating partially the equation, differentiating partially number 1 the equation with respect to x and y. We get what we get. So, this side will be del z by del x, and this is y is because x with respect to x you are doing, it means y is a constant, and there is no multiplication rule you will be applying. It means y plus b is a constant and x plus a derivative will be 1. Now, with respect to y if you will do, so the same way x plus a will be treated as constant. Sometimes what you do, you just apply a product formula, product rule you apply, there is no need to, because the other variable is getting or becoming constant when it is the concept of partial derivatives. Now, you see what to do. So, clearly you see, observe the or just have a look on the given equation. आप देखो multiply अगर आप करते हो, so I am just this time I am multiplying. So, multiply 2 and 3 because my given equation is giving me idea that I should multiply. So, when I am multiplying, this equation is becoming as y plus b into x plus a, and you can see this is given to be z by the given equation. This is p. Now, in this is p notation, this is q. So, now you can see pq equal to z, the equation we were looking for. So, and this is multiplication of partial derivatives. So, this is non-linear, and this is how we removed the two questions I have taken on this problem. Now, we have two types of two more types in which we find partial differential equations, that we will be learning just after the break.
Welcome to S. Chand Academy, myself Dr. Mamta Sethi, and I am here to explain you the various concepts related to the states of matter and chemical kinetics. So, stay connected, like, subscribe and share, and do not forget to press the bell icon.
Welcome back to S. Chand Academy. So, before going to the break, we learned how to form partial differential equation when two constants or more than two constants, or if there is one constant given in the solution or in the form of z equal to some constant and x and y. So, now I will be learning if your equation is of the type which I am just taking, this will be the second type for formation of partial differential equation. So, the type you can say it has the type is f of this form. If this is the type, then how you will be forming partial differential equation? It means in this case you have to remove this one, only one function is there. So, you will be removing this function basically, and this type has standard method, or you can say the steps are similar whichever question you are getting. It means the same steps you have to follow. The question will keep changing, but the steps will be the same. So, example based on this, with the help of example only we will be doing. So, what example is, suppose you have this equation and you are asked to find out, or you are asked to form partial differential equation. What you will be doing? So, as I told you, the method is standard one. First, what you will do, you just let u as x square plus y square, v as z minus xy. So, your function will look like f comma u comma v equal to 0. This is the form we are used to of, this is the form we are not used to of. So, that is why I have considered u and v, and my equation looks simpler. Now, what will be the next step? First, you see your u is function of x and y, your v is function of x and y, z is understood. So, how you will be taking now the derivative, and it is u and v. So, the derivative will be same. So differentiating 1 with respect to x partially, or you can say taking the partial derivatives of 1 with respect to x. How in this case you will be taking? So let's learn. Now I am just making the chain which I did in the semester 1 also. The chain, if you write for partial derivatives, if you make the chain, it becomes very simple for you to take the partial derivative, otherwise it is very difficult. So f is function of u and v, and your u and v both are functions of x and y. So now how with respect to x you are taking na? So how many chains with respect to x are ending? 2 chains you can see clearly. So it means f partial derivative with respect to u and then u partial derivative with respect to x plus f partial derivative with respect to v and then v derivative with respect to x. This is how you take the derivative. This is called chain rule. So it means f derivative with respect to u first, then for the chain we multiply, and if it is a different chain we add. So this is one chain only, f derivative with respect to u, then u derivative with respect to x, plus f derivative with respect to v and v derivative with respect to y. This is how you take the derivative in this case. So this is important. Chain you got to know how we are forming and then how we are writing the derivative. Just write this you cannot define, del f by del u you cannot define, but you see what was your u. So u was, clearly see, your u was x square plus y square. So what will be del u by del x? I am filling the values here because these two values you can fill up and you should write before moving to the partial derivative with respect to y. So del u by del x, if you are doing, it means x is variable, y is constant. So it means simply 2x, because y derivative will be 0. So 2x plus 0, it means 2x only. So I am just writing this value plus del f by del v. Now v is what? V function. So my del v by del x, this is now a very important. Don't ignore z, because z is also function of x and y. It means z derivative with respect to x, we have some value. So I am writing del z by del x because it has derivative with respect to x. It is function of two variables. Now this is product, y is constant. So simply y, and simply this value I have given a notation p. So it means my del v by del x, I will be putting the value p minus y. So this is done. This is my, this is the equation. What one more step you just do, and what is the step? These are the standard steps. In each and every question you have to just repeat the same way. Only the question u and v will be changing, otherwise same steps you will be following if this type of question you are getting. I have taken this to this side. So it means now we are done with respect to x, we are done. Now moving to partial derivative with respect to y. So the same way you will be taking, it means two chains are ending at y. You can see two chains are ending at y. So for one chain multiplication, and if it is another chain, plus sign you will be using. Two chains are there, it means the first chain plus the second chain. So del f by del u by del y, because this time it is with respect to y. So del f by del v by del y equal to 0. Put up the values. So del u by del y to y, and the same way del v by del y, just it will be instead of p it will be q, and instead of y it will be x. It just on the similar parallel lines you can write. Now put up the values. So del f by del u by del y is 2y, del f by del v, then q minus x equal to 0. So del f by del u 2y equal to, now take it to that side, and now you see these two equations. If you see, if I divide these two equations, now you see this is same, na, this is same. this is same, it will get cancelled and your partial derivatives f, the variable, the function will get removed. It means we should divide these two equations. So, I just number it as if I haven't numbered yet, so 1 and 2. So, dividing 1 by 2, what will get? Del f by del u 2x equal to divided by equal to then del f by del u to del u 2y, then minus del f by del v, and as I told you, the steps will be just the same, particularly for this type of equations. So, this will get removed, 2 also gets cancelled. So, it means my final equation is x upon y, minus also will get removed, p minus y upon q minus x. I can just simplify it move further to get the partial differential equation, but this is fine if you leave it here also. It is fine if you cross multiplying then arrange, then also it is fine. So, this is the partial differential equation in this form. Now, the third type I will be discussing, and the third type is, that is the case in which you have two functions. So, this is, you can say, type 3, removing two functions. So, type 3, removing two functions, and example I will take up, and the equation will look like this. So, you can clearly see in this equation we have two functions. So, how to remove these two functions? Let us see how to remove. So, first step will be same, differentiating partially with respect to x and y. What basic the equation will get? This is del z by del x and we have called it as p. Now, this is a function and the variable is x plus at. It means, suppose you have sin t instead of this. So, how you will take the derivative? First you will take sin t derivative, then the angle derivative. It means the same you will do here. First the function derivative and then whatever inside you have, you will be taking the derivative. And please just in this question I have written y, make a correction please. What correction? It is not the variables this time are x and t. It means the second variable is not y, it is t. So, it means first with respect to x you will be taking the partial derivative, then with respect to t. So, derivative of this with respect to x is just 1. So, multiplication with 1, then same way you apply or you do the partial derivative for g function. Now, the partial derivative with respect to the second variable. So, what will be the derivative? The same way and at. So, t derivative will be 1 and it is simply a. Then g dash x minus at, this time the derivative will be minus a, x derivative will be 0. So, two equations we got, one is p equal to x plus at, g dash this, then second is q equal to a f dash x plus at. Now, you can see that the given equation and the two equations which we have got no connection at all. It means there is very difficult using these three equations to remove the two functions. It means we have to go to the second order partial derivatives. There is no other way. So, the second order derivatives will be taking. So, with respect to x I am taking. So, I just number this as, there is no numbering yet. So, I can number it as 1, 2. So, I just differentiate it with respect to x one more time. So, when I will differentiate it one more time, it means this becomes del square z del x square. It means that will be r, that is del square z. It means second derivative with respect to x. This is first derivative na. So, we are taking second one more derivative. So, the equation will look like, so second derivative x derivative is 1 the same way second derivative and the x derivative will be 1. Now differentiate this also with respect to y one more time. So differentiating 2 with respect to y. So what it will become? It will become t, that is del square z upon del y square. So this will give me f double dash x plus at. Then a already we have and one more a, so it means a square. Then from this equation 1 minus a already, and then one more minus a will become a square and g double dash x minus at. Now you can see some similarity. You can see this is double derivative, double derivative. From this equation I just take up a square common, and I can replace this simply by r, that is my this, and this is my t. So this is the equation we were looking for. Now we have removed. So anyhow this is the case, little difficult, but you have your first order derivatives, second order derivatives to get to remove these two, the two functions which were given in the equation. So this is how you do it. So in this lecture we have learned two types, in which second type we were having one function, in the second we were having two functions. We removed the two functions to get the partial differential equation, and one more case we discussed. In that case we were having constants. We learned how to remove the constants. So in all three methods for the formation of partial differential equation. If you want to study this topic in detail, please refer to the book by S. Chand Publishing. The e-book link is given in the description box below. Don't forget to share, like and subscribe S. Chand Academy. Don't forget to press the bell icons for the future updates. Stay connected, stay tuned. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.